a mysterious wanderer streaking through the cosmic dark. It went behind the sun, now it has reappeared. The interstellar visitor named 3I Atlas has returned, but it's strangely glowing bright.
On October 29th, 2025, something happened that has scientists scrambling to rewrite the rules. An interstellar visitor, something that's been drifting through the galaxy for up to 12 billion years, made its closest pass to our sun. And what it did next has triggered something unprecedented. The United Nations activated planetary defense protocols for the first time in history for an interstellar object, not because it's heading toward us, not because it exploded, but because it's behaving in ways that shouldn't be possible. This thing, astronomers are calling it 3I Atlas, has been floating through space since before our sun even existed. Think about that for a second. It's 3 times older than Earth. Every star system it passed, every radiation field it traveled through, every gravitational pull over billions of years, it survived all of it. And now, it arrives here, swings past our sun, and starts doing things our models can't explain. Telescopes across the planet were locked onto this visitor, and what they captured has researchers at observatories from Tongjiang at LOL Observatory to Carl Bams at the Naval Research Laboratory asking the same question. What exactly are we looking at here? Because the brightness readings they're getting don't match anything they predicted. Instead of following the expected curve, the brightness spiked hard, twice as fast as the weeks leading up to it. And that's just the beginning of what makes this object so deeply strange. Before we dive deeper into this story, make sure you hit subscribe and turn on the bell so you don't miss the next video. Alright, back to it. When scientists broke down the light coming from 3I Atlas, they found something that sent alarm bells ringing. This wasn't just reflected sunlight bouncing off ice and rock. The object was actively emitting carbon compounds and water molecules at a rate 40 times higher than observations from just a month earlier. Imagine turning a faucet from a trickle to full blast in an instant. But here's the problem with that comparison. Comets don't work like faucets. They don't have on-off switches. The physics is simple and predictable. As a comet approaches the sun, it gradually heats up. Ice turns to gas slowly, steadily, following smooth curves that we can calculate with precision. Then as it moves away from the sun, it cools down just as gradually. We've been observing comets for centuries. We know how they behave. But 3I Atlas threw that playbook out the window. Space observatories that can track objects near the sun, SOHO, Stereo A, GOES 1 Newton, they all captured images during the closest approach. And here's where things get really odd. The shape was elongated, check. The glow was visible, check. But where's the dust? When comets heat up, they produce dust. That's what creates those spectacular tails we've photographed for generations. That's what scatters sunlight and makes comets visible to the naked eye from Earth. 3I Atlas barely has any dust at all. Some researchers scrambled to explain this with a hypothesis about carbon dioxide acting as a protective shield early in the approach. Carbon dioxide sublimates at colder temperatures than water ice, so maybe it was creating a cooling effect on the surface. Then right around perihelion, that closest point to the sun, that layer burned off completely. Suddenly the water ice underneath was exposed to direct solar heating. Boom. Brightness surge. It's a reasonable explanation that fits known physics and explains the timing. But there's a catch. It requires a very specific internal structure, a layered composition that we've never observed in any comet from our own solar system, which raises an uncomfortable question. Where did this thing form? And what conditions existed around its parent star? Before all this happened, back in August, the James Webb Space Telescope took a long look at 3I Atlas. Webb's instruments can analyze molecular signatures with incredible precision, breaking down the chemical fingerprints of objects in space, and what they found created its own set of mysteries. The surface of this object has been fundamentally altered by radiation. Not radiation from our sun. It wasn't close enough for that yet. Radiation from space itself. Cosmic rays, high-energy particles from supernova explosions across the galaxy, have been bombarding 3I Atlas for eons. These particles don't just hit the surface and bounce off. They penetrate deep, sometimes dozens of feet down, changing the molecular structure at a fundamental level. According to Roma Maggiolo, who led the analysis at the Royal Belgian Institute for Space Astronomy, computer models suggest this radiation has created a crust approximately 50 to 65 feet thick, covering the entire object. This isn't a thin coating. This is a shell that no longer represents what the object looked like when it first formed billions of years ago. It's been processed, modified, transformed into something different during its journey through interstellar space. Here's why that matters for what we're trying to figure out. Scientists were hoping that interstellar visitors like 3I Atlas would give us direct samples of material from other star systems, a way to study how planets and comets form around different types of stars in different chemical environments. But if Maggiolo is correct, we're not looking at pristine material from another stellar neighborhood. We're looking at a radiation-modified shell, a protective layer that formed during billions of years of exposure to cosmic radiation. It's like trying to study an ancient artifact that's been buried in corrosive soil for millennia. The original surface is gone, replaced by something else entirely. The question now becomes, is there anything original left underneath? Did the intense solar heating during perihelion erode enough of that protective crust to expose material that hasn't been modified? That's what observers are watching for in the data. That's what the next few weeks of analysis might reveal. Because if we can find unmodified material, we might actually learn something about the stellar system this object came from all those billions of years ago. But here's where the story takes a turn most people haven't heard about yet, and it's the part that should make everyone pay attention. On October 21st, 8 days before 3I Atlas made its closest approach, the International Asteroid Warning Network made an announcement that broke a pattern. They published it through the Minor Planet Center, stating they were initiating a coordinated observation campaign targeting 3I Atlas. The campaign would run from November 27th through January 27th, 2026. Now, IWN conducts exercises regularly. They've done 8 of these campaigns since 2017, roughly 1 per year. They use them to practice coordinating global observations of potentially hazardous objects, asteroids that might pose collision risks, near-Earth objects that need precise tracking, standard procedure for planetary defense. But here's what makes this different. They've never targeted an interstellar object before. Not once in the entire history of the organization. This is the first time ever. Why target something that's already moving away from us, something that poses zero collision risk to Earth? The official explanation is technical and sounds reasonable. Comets are harder to measure precisely than asteroids because their fuzzy atmospheres and tails make it difficult to pinpoint exactly where the nucleus is located. IWN wants to practice these measurement techniques on 3I Atlas because it's a good test case. That's legitimate. That's a real scientific rationale that makes sense. But 3 weeks before this announcement, Professor Avi Loeb from Harvard submitted a white paper to the United Nations. The paper, co-authored with researchers Omar Elde and Gershon Tenenbaum, made a specific recommendation. The international community should coordinate observations of interstellar objects with maximum coverage, global cooperation, and comprehensive data sharing. The reason stated in that paper? These objects could pose a threat to humanity if they happen to carry technology from another civilization. Now, I'm not suggesting IWN activated their protocols because they believe 3I Atlas is artificial. But the sequence of events is worth noting. White paper submitted September 30th. IWN activation announced October 21st. First interstellar target ever selected. And then there's what happened on October 29th that makes all of this even more significant. The Atacama Large Millimeter Array detected something specific. 3I Atlas was not where pure gravitational calculations predicted it should be. The deviation was measurable. 4 arcseconds in right ascension. That's small, but it's real. It's documented and confirmed by multiple independent sources. This means acceleration. Not just the normal acceleration from falling toward the sun and then moving away. Additional acceleration. Non-gravitational forces acting on the object. NASA's Jet Propulsion Laboratory quantified this through their navigation engineer David Fernanoia. 2 components of acceleration detected. Radial, pushing away from the sun. Transverse, perpendicular to that radial direction. Both measurable, both requiring an explanation. The conventional answer is outgassing. As ice sublimates into gas, it escapes from the surface carrying momentum. Newton's third law says the comet experiences an equal and opposite force, like a natural rocket engine driven entirely by solar heating. Professor Loeb ran the numbers on this. If outgassing explains the measured acceleration, and if we assume reasonable gas velocities based on temperature, then 3I Atlas lost approximately 1/6 of its total mass during the perihelion passage. We're talking roughly 5.5 billion tons of material ejected into space over just a few weeks. That's an enormous amount. And if it really happened, there should be visible evidence that's impossible to miss. A massive cloud of gas surrounding the object, expanding outward, glowing, detectable by spectroscopy, obvious in images from any decent telescope. This is the test that everything hinges on. Starting in mid-November, when 3I Atlas emerges from the sun's glare and becomes visible again from Earth, observers will be looking specifically for that gas cloud. And on December 19th, when the object makes its closest approach to Earth at 267 million kilometers away, hundreds of telescopes will be aimed at this single point in space. Professional observatories, space telescopes like Hubble and Webb, even amateur astronomers with good equipment, everyone will be checking for the same thing. Is the gas cloud there? If yes, if observations confirm a massive cloud containing billions of tons of ejected material, then the natural explanation holds up. 3. I Atlas is a comet, unusual in composition, extreme in behavior, but ultimately explainable through known physics applied to an exotic object from another star system. Case closed. Mystery solved. We learned something interesting about how different stellar environments produce different types of comets. But if December observations fail to detect the expected gas cloud, then we have a serious problem. Because the acceleration is real. It happened. It's documented by multiple independent measurements. And if outgassing didn't cause it, what did? Loeb stated this explicitly in his analysis. If no gas cloud is observed, the reported non-gravitational acceleration near perihelion might be regarded as a technological signature of a propulsion system. This isn't wild speculation or science fiction. This is the scientific method applied to an unusual observation. We have a clear prediction. Natural outgassing at the level needed to explain the acceleration requires a visible gas cloud. December observations will either confirm or falsify that prediction, and we adjust our understanding based on what we actually find, not what we want to find. There's historical context here that makes this test even more critical. The first interstellar object, Oumuamua, also showed non-gravitational acceleration when it left our solar system back in 2017. Deep searches by the Spitzer Space Telescope found no gas, no dust, nothing that would indicate active sublimation or outgassing. That's why some researchers proposed it might be something artificial, maybe a tumbling light sail, thin and reflective, pushed by radiation pressure rather than jets of gas.
Most scientists disagreed with that interpretation. They argued there must be some form of outgassing that Spitzer couldn't detect, maybe exotic ices that don't emit in the wavelengths Spitzer was monitoring.
It's always easier to imagine unusual but natural chemistry than to seriously consider artificial origins. But now we're seeing something eerily similar with 3I Atlas. Non-gravitational acceleration, check. A test case where we can actually check for the expected gas cloud with better instruments than we had for Oumuamua. If it's not there this time, those Oumuamua questions come back stronger, harder to dismiss. Meanwhile, right now as I'm recording this, the European Space Agency's JWST spacecraft is observing 3I Atlas from a unique vantage point. JWST, the Jupiter Icy Moons Explorer, is on its way to study Jupiter's moons, but in early November 2025, it's positioned where it can observe the comet just after perihelion, during what should be its most active phase. The observation window opened November 2nd and runs through November 25th. JWST is using multiple instruments, visible cameras, infrared spectrometers, sub-millimeter wave detectors, particle sensors, gathering data that no Earth-based telescope can match because of the viewing angle. On November 4th, JWST made its closest approach to the object, 64 million kilometers away. That's close enough to resolve structure, close enough to measure activity levels with precision, close enough to detect things that might be invisible from our perspective on Earth. But here's the frustrating part. JWST is so close to the sun right now that it's using its main antenna as a heat shield to protect its electronics. Data transmission is severely limited. Everything being collected during these critical observations won't be downloaded to Earth until February 2026, 3 months from now. So we wait. We wait to see what JWST saw during the most important observation window we'll ever have of this object. By the time that data arrives, we'll already know the results of the December gas cloud test. We'll already have answers to some questions, and probably a whole lot of new questions we haven't even thought of yet. Watch what happens in December. That's when everything becomes clear. That's when we see whether natural processes explain everything, or whether we need to seriously expand our thinking about what travels through the space between stars. The visitor is here, the observations are ongoing, the tests are designed, and over the next few months, we're going to find out what this thing actually is.